Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Versant. We have Robert Greene, who's the VP of Technology Development. Welcome to the show, Robert.
Thank you very much, Rich. Glad to be here today and help spread some good informative news.
All right, that sounds great. Well, hey, I have your slides up on the screen, so why don't you go through those, and we'll follow that with a Q&A.
Okay. So on the first slide, then, you can see that we're here today to kind of talk about the NoSQL 2.0 ABCs, and that's to frame the perspective of the use of NoSQL technology in some of the database-related work that's going on these days. If we go to the next slide, we would like to characterize the shift in NoSQL and what does it mean to be NoSQL. And this is talking about traditional database scale architecture. Many of you probably realize that a traditional databases scale through mostly a shared everything, but on occasion a shared nothing type of architecture, where the client applications are sending information across the wire to the relational database servers, which are doing join operations in order to bring that data together to the application space. So that process of repetitively asking the database server to recreate relationships between data all the time turns out to be a really bad thing, especially in a high-performance computing type of environment. And as it turns out, most models, especially in things that you see in HPC space like simulations, et cetera, relations don't really change very much. It's kind of like blogs and blog articles or orders and order items. I mean, once those things are put together, they really stay together. So the database server doesn't make sense to keep asking for those again and again. Plus, at the same time, traditional database technologies have a type system, which is very different from the application space. And so when you move the information out of the database, once you finally recalculated a join, it actually has to reconstitute into a runtime object, and that's also a very CPU expensive operation. So going to the next slide, NoSQL at its core, what we really think that the value that NoSQL is delivering is it's allowing you to think differently about data relations. And it's giving you the ability to unify the application schema with the database schema. And that eliminates a lot of those problems that we talked about before. Google refers to it as soft schema. IBM and others often refer to it as schemaless. We don't think it's schemaless because at the end of the day, any of these database technologies in this space are really, they're putting some kind of structure to the data. I mean, data is not really useful until it attains some structure, and structure is schema. So we prefer to use the terminology soft schema, but it allows you to use commodity hardware and scale this stuff out because the data management is part of that soft schema or the data relations. And so by controlling those relations from the application space, you can get at that information wherever you spread it out across a partition system very efficiently. So it's really highly performant, and at the same time, it's highly scalable. So that advantage in bringing scale through partitioning and through data relationship management in the application space makes a lot of sense. I mean, as I talked about earlier, if you think about it, looking at the next slide, most relations don't change. So the whole idea behind this NoSQL trend is to stop, hitting your head against this relational wall, stop recalculating those relationships over and over again, and partition and distribute your data for performance and scale. So moving to the next slide, we've tried to distinguish now between pure NoSQL sort of 1.0 scale and performance and NoSQL 2.0, and that is moving beyond this notion of just a pure key value store. I mean, what was really important in the first generation of NoSQL technology is that ability to get the performance and the scale. But unfortunately, with using something as rudimentary as a key value store, it introduces lots of issues that has to get dealt with in the application space. You have to write a bunch of additional code layers to monitor what's going on, and you have to put corrective actions in place in your code when things don't sync up in the right way. And You've got to write layers to marshal things in and out, and create reference systems to know when you've already marshaled things and when you truly need to fetch them. And so it's a bunch of burden that gets put on the developer because you're using something which is so basic in form. So NoSQL 2.0, we say, is technology which delivers that scale and the performance that you get from soft schema, but also allows you to write things in your native, C++ type of environment in the HPC space in particular, or even C or Java or other languages, and have that schema in the application space really reflected in the database technology itself. So it moves beyond this sort of simple partitioning and allows more interesting behavioral type of partitioning of the data according to how it is that things interact with each other, and gives you a much richer distribution and scale concept. Also, it allows you to do things like take into consideration network traffic. When you're loading data back and forth across the network, you don't, if you're as discrete as a key and a value all the time, even if that value is a sort of an embedded structure, a document, if you will, it can create a lot of chatter, especially when you're trying to do that efficiently. Many of the NoSQL first generation sort of document storage, for example, you would just bring little pieces of data out as you need them from inside the document. You can just imagine how much network chatter that is. So second generation NoSQL technology takes that kind of network element into perspective and allows you to use certain APIs to optimize network traffic and ask the server to group things together for you before you move them across the networks and things like that. So it's even one step beyond a basic key value store in delivering performance. At the same time, you get things like parallelization. So you need to query, and some of the first generation NoSQL technologies have introduced query concepts, but we suggest that query is an integral part of any database system. It's sort of how you enter your use cases. You query with some interesting predicates and criteria. You get some stuff out. Once you got it out, now you've got a rich model, and you can start to talk to it, and you can start to move around, and you use those the data relations being managed by the soft schema. But you got to query to get into that use case, and so having parallel server-side queries is very important to the technology choice. So looking at the next slide, we talk about moving beyond keys and values. This first generation NoSQL stuff did not really address information model complexity, which, I mean, the models you find in the HPC space. It could be some very, very complicated simulation stuff, where the models are actually dynamic and changing from run to run. So you have a lot of difficulty dealing with that in this first generation of stuff. So you see the market responding. You see people trying to build layers on top of this first generation of stuff to make it more amenable to the information complexity. You see things like PIG being introduced on top of Hadoop. You see inner document references being introduced into document stores, or you see things like Cassandra expanding beyond a key and a value and creating these super column structures so you can embed more rich information underneath those keys. And that's all a reflection of the market saying, hey, there is complexity in our models, and you need to do more than just push things in and out in a stupid way. And so second generation NoSQL's technology should deliver something which is beyond just pure serialization, gives you full graph structures, lets you move around those graph structures, and lets you do that in a way that reflects the real complexity in your information models. The issue is real. Things like Hadoop, will give you an interesting scale capability when you want to churn through some raw data. But once you get that data back, generally you need to put it in some sort of interesting model where you get quicker responses because now you know it. That there are questions there that you want answered rapidly. So you have to stuff that into a different model, and it just doesn't work well if you're trying to do it with, again, those technologies that didn't solve that problem well to begin with. So you need to couple these things to a different type of technology that's soft schema driven and manages those data relations in a much smarter way. And so NoSQL 2.0 is the kind of technology that lets you do that. Again, gives you that performance and scale, but also lets you deal with your real HPC computational models. And so there's a graphic on the next slide that sort of represents what we're talking about here. You can see on the top half it's that sort of partition key value, whereas the second generation stuff, which is on the bottom of the graphic, is talking about next generation sort of partition keys and graphs. And importantly, is those graphs are connected. So while you might do a lot of things that's relevant to some set of grouped business type of object or something which has a natural grouping in your simulation, like molecular structures and atomic structure beneath that, but those things can be connected. So those things can form larger bodies of information which pull all these graphs together. So moving on to the next slide. CAP. A lot of you have probably heard about CAP in these NoSQL 1.0 type of technologies. It's great stuff. Basically people figured out that if I don't do full ACID sort of transactions all the time and all that, I can get better performance. And so they went with that. But it was very much a knee-jerk reaction because these are companies that created these technologies out of sort of desperation. I mean, it was a LinkedIn versus Plaxo, or it was a Facebook versus MySpaces, and it was like, hey, if our systems don't scale to handle these users coming at us, we're dead. And so that's why they ended up with things like key value stores. I mean, they had to develop these things in months. They didn't have a lot of time to do it, and so CAP came into play, and they started sacrificing these things. But it comes at a cost. As soon as you start getting rid of the solid transactions in the systems, then you got lots of code you have to write to compensate for that fact, because if things aren't quite in sync, you need to know it, and you need to correct those things with compensating transactions. It could be as bad as getting down to a manual process where because the system did something not right, you got a guy stuffing an envelope and putting a stamp on it. That obviously has a high operational cost, so you don't really want to do that. So you need CAP where you need CAP, but you don't want to be forced into this model where you absolutely must use CAP in all circumstances. You want to balance that. And NoSQL 1.0 is kind of this, I'm on the next bullet here, it's this 80% CAP and 20% ACID. And the 20% is where some of these document stores have introduced their concept of a weak transaction, where as long as you only change things within the scope of one particular value under a key, well then you can do that in a transaction. But you can't do transactions that span these values. And really, we go on to the next slide, and we look at CAP in production in NoSQL 2.0. You want to have as much transactional capability as you can, because that makes all your operational efficiencies come back into play. It means you don't need to write tons of code, so you turn your evolutionary changes in your models out much quicker. You can add indexes online, and you can back things up, and you can do all those things that the traditional databases normally would have been doing for you. Those are important things. The knee-jerk NoSQL 1.0 stuff couldn't deliver all that because it was we got to get it to market in 3 months, and there's just no way you're going to deliver that kind of a system in 3 months. But this next generation of stuff coming out does bring that stuff into play, and so you get much more robust systems that can handle the needs of real HPC type of computing environments. You find more of an 80% ACID, 20% CAP environment. So it's sort of flipping those ratios. CAP is important. Got to use it in the right circumstances, but you don't want to be forced into that model because it creates lots of inefficiencies in your execution. So we go to the next slide. Just sort of in summary, we see enterprise NoSQL as the evolution of the first generation of NoSQL technologies that are delivering things that businesses, planned businesses, need to operate efficiently and successfully. It's not really knee-jerk technology. It's taking the core value of NoSQL 1.0, the soft schema, the data relationship management, and the scale and performance you get from that, and adding in the rich sort of features that you get and would have expected from a full-on, commercial type of database infrastructure. It's beyond keys and values. It's keys and graphs. It's transactions, support for complex information models, robust full query engines, and getting all that in a way that's manageable in a production environment. So going on to the next slide, there's a graphic that sort of depicts what we're talking about in Versant. Versant obviously is in the NoSQL space, historically in an object database technology. But as it turns out, object database technology, in fact, delivers all those core values you find in the NoSQL space. It was, again, it's soft schema. It's data relationship management that's baked into the storage system, and that's been the object database space all along, and that's what puts us in NoSQL. But again, 2.0, it building all of these robust features that really are needed in an average business, so that they don't need a mountain of developers constantly holding all this stuff up, and it can just run and work and enable your business as a technology should. And so that's it on the slides. And from there, I'd love to hear some questions, Rich. If I've sparked any hot topics for you.
Yes. Absolutely, right. So I had a long run at Sun Microsystems, and we had this old adage, right, that you date your hardware vendor, but you're married to your data. For this kind of approach, Robert, is it more evolutionary? I mean, is it something they can easily migrate to this new kind of model?
Sure, yeah, that's a great question. And the answer is yes. It's interesting that you said that, that's a history of yourself at Sun, that you made these observations. Few people realize it, but actually Versant was heavily involved in object relational mapping 10 years ago. And the reason we were heavily involved in that was because object relational mapping presents a soft schema approach over relational database technologies. And so it was actually the original product manager for our company, a guy named Craig Russell, who went to Sun Microsystems and formed the JCP on the Java side to deliver this sort of this ORM technology. It was called JDO. And that sparked a number of years where open source technologies came into play, Hibernate, and the whole EJB community was there with their entity beans, and it sparked a lot of debate and evolution. And ultimately, people came up with what's accepted today as the JPA standard. At least I'm talking in the Java world. And in that world, that standard, every time you download Java, that's the interface to deal with databases these days. And in fact, that's the interface to deal with our database as well. So, and all that stuff really, the whole POJO persistence model and object lifecycle management as being the most important thing about dealing with soft schema. Actually, a lot of that was driven through Craig Russell, which was the guy who defined our interfaces to our database quite some time ago. So if you're an expert in using Hibernate, for example, over Oracle or MySQL, or you're pretty much an expert in our technology, and your data can move between these different types of technology through that interface. I mean, there's other ways. You can import and export XML, and you can do things like that as well. But in terms of the data movement side of things, but yeah, these technologies are evolutionary in that respect. They're revolutionary in the shift in mindset to soft schema, that people are finally realizing that, hey, there's a smarter, more performant, more scalable way to do data management. But when it really gets down to where the rubber meets the road and the guy has to make some, code some things up, it looks just like standard JPA.
So, Robert, as I peruse through these kind of materials, it seems everyone's talking about big data and the explosion of unstructured data, coming from the various sources.
Mm-hmm.
Does this model have a play there as well?
Yeah, absolutely. I mean, if you see what people are doing with our technology, I mean, in the HPC space, a lot of what people would be classifying as unstructured data. Frankly, I would classify it as highly structured data. European Space Agency mapping the infrared spectrum of the universe, storing that inside our database, and then creating analytic layers above that to deal with these images, for example. That's the kind of thing that's going on in our technology. Recently, and you would probably consider this unstructured as well, a month and a half ago, Medicare, Medicaid, on a national basis, just rolled out a fraud system for healthcare. That's based on our technology. It's a project that was awarded to Verizon and Northrop Grumman. It's a system that they've been running for quite a long time in the telecom fraud space, and it's also doing fraud for finance. It's doing fraud for healthcare. Massive system. It's a national scale healthcare system detecting fraud claims. And you can imagine what the structure of that information looks like. You've got documents coming in from all the claims processing from all of the health insurance providers, and it has to go through all of that data and make some sense of it and detect patterns. But this notion of structured, unstructured data, I think, is a bit of a misnomer right now out in the industry. I mean, I think that even things that are dealing with what people think of as unstructured data, like log records in a Hadoop, for example, I mean, that stuff has structure. It's a simple structure, but it has structure. And, something like Hadoop might churn through some log records, which is a structure it understands. And when it gets answers from that, it puts it in yet another structure. And so I really prefer not to talk about things in terms of schemaless or unstructured. I think pretty much everything has got is either highly structured, which to the point where it appears unstructured, or it's got some moderate complexity to it.
So, kind of just a wrap-up question here, Robert. You're a technologist. What does a 3.0 version of this look like as you guys look forward?
Well, I think a 3.0 version of this is something which is got a lot of automation in it. I mean, I think that 3.0 really comes down to the tools. And when I say that, I say that from a perspective of an integrated type of tooling environment. It's really unfortunate that right now you've got people that want to use like a distributed file system like Hadoop, and so you've got one set of tooling to deal with that and all of its clusters and its nodes, and then you've got people using our distributed database, and it's got its clusters and its nodes, and then you've got people dealing with distributed file systems and its clusters and its nodes, and it just is a bit unwieldy in some respects. So I think a 3.0 version is looking at a unification of some of that stuff and going, hey, clusters of processes are clusters of processes, and let's get some centralization in how it is that you have to manage and look at all that stuff, and make it so that it's easy and much more quicker to deploy combinations of these technologies where they help each other out and deliver a more complete solution without having to be running all over the place to different tools. So I think it's going to be automation and tools that are really going to drive what will ultimately be version 3.0. Cloud virtualization and all that kind of stuff, all sort of coming under a console to deal with.
Well, thanks for that, Robert. I really appreciate you coming on the show today.
Yeah, Rich, thank you very much for having me, and wish you a great day.
Okay.
And the rest of the audience.
Okay, terrific. Well, that's it for the Rich Report, folks. Stay tuned for more news and information on high-performance computing.